On number 10, we are multiplying the two matrices by hand. And as you can see, I've already labeled my dimensions and shown that the inner dimensions match. So we can multiply these, and I've already labeled all of the different row times column multiplications that we need to calculate. So the outer dimensions of the matrix multiplication are 3 by 3. So my answer matrix is going to be a 3 by 3 matrix. So I first want to do row 1 times column 1. So 5 times 2 plus 1 times negative 1, which is 9. Then row 1 times column 2, 5 times 1 plus 1 times 3, which is 8. Row 1 times column 3, 5 times 3 plus 1 times 4, which is 19. Next, row 2 times column 1, 3 times 2 plus negative 2 times negative 1, which is 8. Row 2 times column 2, 3 times 1 plus negative 2 times 3, which is negative 3. Row 2 times column 3, 3 times 3 plus negative 2 times 4, which is 1. And then lastly, multiply row 3 by all of the columns. So row 3 times column 1, 1 times 2 plus 4 times negative 1 is negative 2. Row 3 times column 2 is 1 times 1 plus 4 times 3, which is 13. And then lastly, row 3 times column 3, 1 times 3 plus 4 times 4, which is 19. So this will be my answer. One last thing about number 10 is that it's the same two matrices as number 9. We're just multiplying in the reverse order, and we get a completely different answer. So this is a good example of why matrix multiplication is not commutative. So the order in which you multiply the two matrices is very important.